point of this quadratic, and we're asked to use inequalities to define R. So in order to use inequalities to define this region, we first need to find the equations that represent these two curves C and L. Okay. So how can we do this? Well, first things first, let's do this with a straight line to start off with. It's very easy. It has a y-intercept clearly of 25. So we know straight away that it has the form y is equal to mx plus 25. And then we just need to find what m is by subbing in this point that we know that it goes through. So we have 13 is equal to minus 2m plus 25. Because to subtract this off, we have minus 12 is equal to minus 2m, or m is equal to 6. So the equation of that straight line is y is equal to 6x plus 25. Now, what about the quadratic? Well, because we know that this point is the minimum point, okay, so we know the coordinates of the minimum point of this quadratic function, we can go ahead and use that to pretty much, again, straight away read off, what the sort of form of this quadratic function should be in complete the square form. So we know a general quadratic in complete the square form looks as follows. So we have a lots of x plus b all squared plus c, where b here is going to be the negative of the x coordinate of the turning point, and c here is going to be the exact y value of the coordinates of the turning point. So therefore we know that it takes the form y is equal to a lots of, and then here we have to change the sign, right? So, hopefully all familiar with completing the square at A level. And then here we have plus 13 on the end. So all we need to do is just fix what a is by, again, substituting a point that it goes through. Obviously not the turning point, okay, because that's just going to give us what we would expect. We need to use different information, so we use the y-intercept. So we go ahead and we substitute in x is equal to 0 and y is equal to 25. So we have 25 is equal to, so then we have 0 in here, okay, for x, so we have 2 squared, so 4a plus 13, okay, and this tells me that a is equal to 3. And then we're pretty much done, right? So we know the equations that describe both of these curves. And the idea is that, well, along these curves, we have, for example, y is equal to 6x plus 25. If we're above this curve, right, above this straight line, then we know that the y value is greater than this. If we're below this, we know that the y value is less than this. Same with the quadratic, right? This line here is exactly where the y value is equal to 3 lots of x plus 2 all squared plus 13. So, if we're either above or below this, right, that sort of dictates, how we can sort of represent this inequality using the y value of these curves. So clearly this region R, the y value is above, right, this curve, okay, so above 3 lots of x plus 2 squared plus 13, but also below this straight line, okay? So if I just quickly fill in, just for completeness, we have the equation of this curve as follows. So what we want is, the y value to be above this, but below this, okay? And it's a strict inequality because it's the region bounded, so we're not including these endpoints or the intersection points, etc. So we can say this as follows, because that y, right,